Good afternoon, everyone. Am I audible?
Yes, I
Good,
audible.
good afternoon, sir.
Yes, sir, you're audible.
Okay. Thank you, everyone. So I welcome all of you to this first class on cloud computing. So before discussing the topic cloud computing, I hope you have syllabus with you. All BTech and MTech students, you have syllabus with you. So the syllabus is a little bit different from BTech and MTech, but I'll try to cover both part, whatever mentioned in the BTech syllabus as well as MTech syllabus. And feel free to interrupt me while I am delivering the lecture, right? So that if you have any doubt or any confusion, or if you want to add something, then you can interrupt me at any point of time during this lecture. And initial few lectures will go through the materials that is available in the public domain, that is our NPTL. Most of you are aware of NPTL. So that in NPTL we have a cloud computing course, and this course is offered by Professor Soumyakanti Bose. He is a professor in the Department of CSE, IIT Kharagpur. So we'll follow the material by Professor Ghosh, and after a few introductory classes, we will see some of the specific topics which is mentioned in your course. Okay, so to introduce myself, I am Dr. Sanjay Kumar Panda, and I'm working as a assistant professor in the Department of Computer Science Engineering, NIT Warangal. Your head of the department, Dr. Sandeep Kumar Das, he is my senior and one of my good friend. So he requested me to take this subject for you. Initially, I have planned to take this subject offline, but due to some circumstance, I'll take it online. But if it is possible in the month of April, then I'll visit your campus and I'll discuss about the practical aspect so that you can do also hands-on or lab work with me so that you have an overall idea about this particular subject. And if you see this subject, most of you are going to join industry in the next year. I hope all of you are in final year, right? Can anybody respond? BTech students, you are in final year or pre-final year?
Yes, sir. Sir,
Final year,
final year,
okay.
sir.
Yeah, okay. So most of you are going to join industry next year. So irrespective of the industry, you will see they are relying on cloud computing. You may work in different projects other than the cloud computing area as well, but you will see definitely when end of the day you can see we are using cloud in the background. So this subject will help you to understand some of the concept which you may require when you join the industry, as well as if you are assigned with cloud computing related project in your industry, then definitely this subject will more help you because you know the background, you know the basics related to cloud computing. So I hope whatever discussion we'll make in this particular course, that is 40 hours course, so I hope this will be beneficial for you as a part of your career and as a part of your industry career as well. So let us start with the basic, and please try to interrupt me because it is an online class. So if you interrupt me, then it will be more interesting. It may be a silly question, it may be a tough question to address, but please try to ask questions. Please try to clarify the things in much better way. Wherever you are finding a simple doubt, simply unmute and ask, or you can write in the chat box. So I'm looking into the chat box. If any question is there, first I'll try to address the question, then we'll proceed further. Okay, so let us start with the basic background of cloud computing. So the term cloud computing is new. If you go back to 15 years back, like in 2008, if you see this topic is completely new, and not only for academician like us, but also it is a new term for industrialist also. Industry also, they are looking this particular word as a new term. But if you go to the underlying technology which makes cloud computing popular, such technologies are not new. These technologies are there in long back, I can say prior to 2008, but you can say they are not properly utilized, or their advantages are not taken proper care, by which that cloud computing is nowadays popular term, because it has used these terms, used this implementation, used this underlying technology, which makes cloud computing is a popular platform. We'll go in detail about this one, but let us see these two words, cloud and computing, right? So what comes to your mind when you say about this word cloud? Can anybody tell? When we read this word cloud, what comes to our mind? What comes to your mind when you read the word cloud? Internet. Somebody answered internet. Yes. So if you go internet way, I'll tell you, somebody told about the storage. Yes, in day-to-day life also we use storage. As you are a computer science related student or CS student, you can visualize it in the form of www, World Wide Web, or internet, or storage, or many different things, right? But if you ask your friend who is not belongs to computer science background, he will tell you to look into the sky, right? And he will tell you, see, that is called as cloud, right? You simply point towards the sky to introduce the word cloud. Okay, there is a normal term cloud. As you are CS background, you know little bit related to the cloud, and day to day we are using various services provided by cloud. That's why we visualize cloud as a internet, or cloud as a storage, cloud as a computation, cloud as a network. Different terms we can explain cloud. Second word is here, that is called as computing. What do you mean by computing? Can anybody say computing?
So performing some operations.
Exactly. If you want to do some operation, that is called as computing, right? If you are not aware of computing, you can say in childhood we have calculated 2 plus 3. Somebody shown as 2 finger followed by 3 finger. Then he or she told you to count the number of finger, right? So you counted the number is 1 plus 1, 2, 3, 4, 5. So that is nothing but the sum of 2 plus 3, which we call as a calculation. This term is called as a calculation. Moreover, you can say we have calculator, right? Calculator performs some work, like popular operations are called as addition, multiplication, division, subtraction, modulus operation. Lot of operations we are doing with the calculator. But when we deal with the complicated task, okay, calculator is also having limitation. Like if I ask you, type uh, 16 to the power 512, right? I'm writing 16 to the power 512. Then if you type in your calculator, calculator may not give you the result, right? Because it has limitation, right? So, but if you go for computer system can do a complicated task. Okay, as somebody mentioned about operation, right? The same operation what we are doing in a calculator, we can do the same operation in our computer system as well. But simple operation case, we can use calculator, or a small handheld devices like our smartphone is also having calculator, right? But when you go for a complicated task, we depend upon a computer system, right? And computer does the computation, calculation. We call it complicated tasks. We call that as a computation. So the word computing is not new. The word cloud is also not new, right? Cloud is already there. You can say from the birth of our universe, right? Computing word is there from long back, right? Starting from calculator and counting, people know about the computing. But the term cloud computing is new in 2008, not today. Today, each and every computer science related or non-CS people, they know there is a subject called cloud computing. They may not aware of that what we are studying in that, but they know cloud computing is a very popular subject or popular, you can say popular technology that is used in many applications, right? So computing means what? You can say you want to perform some task, right? By the help of our CPU. If you represent a particular task, like if I say I'll give a particular assignment to someone and I'll ask you to solve this assignment by tonight, right? So I assigned some task to someone, okay, a particular person or a student, and I told that it need to be completed before midnight. So you have a deadline for that particular task. How that person is going to execute that task? For execution of that task, the person should have experience that how to deal with that particular problem. In the similar fashion, in our computer, we have instructions. We have different type of instructions. Like you have downloaded a movie, the movie is stored in your download folder in C drive. You want to move this particular movie from C drive to D drive. That is also a task. You have written a very simple program. Let it be addition of two number program. You want to run it and you want to see the output. There also we are doing some kind of computation or some task we need to execute. Some instructions we want to provide through which we are going to execute such instruction by the help of our computer system. There is another popular word when you look into cloud computing. There is another word called as communication. Can anybody differentiate between computing and communication? What is the difference? Now you know a little bit about computing, but how it is different from communication? Computing and communication. What is the difference? In what way one is different from other? Any idea? Communication. Like if you ask your friend, those who are specialized in electronics and communication engineering, they are studying two different topics. One is called as mobile computing, another is called as mobile communication. But these two subjects are different, mobile computing and mobile communication. But here we are saying cloud computing, but you will not find a subject called cloud communication. So you should know what is the difference between computing and communication. Anybody can guess what is the difference? Any answer? Okay. Let us see what is the difference between computing and communication. Are you aware of directed acyclic graph? Yes or no? Data structure, you have studied directed acyclic graph. Have you studied or not?
Yes, sir.
Yeah. So let me draw a directed acyclic graph here, right? Suppose this is my root node A. A is connected to another node B. A is also connected to another node C. And B is connected to another node D. C is connected to another node E. And there is also a dependency between B and E. Right? This is directed acyclic graph. So if you look into directed acyclic graph, I'll tell you each and every node is called as whatever each node consists of a set of instructions. Okay. In order to complete the task A, you need some you need to execute some instructions, right? So who is going to execute this instruction? CPU is going to execute these instructions. As a user, we are giving instruction to our computer system. Our computer system is executing that instructions. That's why instructions are in million instructions, then I called it MI, but processing power is calculated in terms of MIPS, right? This is a specific unit I am telling you. Instruction, the unit is MI, system unit is MIPS. Somebody is asking what is the speed of your CPU, then we say this is MIPS. Okay. So if you divide these two terms, you will get second. That says how much time, okay, is required to execute a set of instruction into a computer system. Right? That is comes under the execution time of that instruction, set of instruction in a computer system. Now, suppose A is nothing but, suppose in A I am doing C is equal to A plus B, right? A and B value is given input, then you have to add these two value and store in C. Okay, that work we are doing in A, right? Now if you come to B, B is calculating C plus A is equal to D, whereas C is calculating D is equal to C minus A. Now you can see the dependency, right? Here you can see this particular instruction which we are going to execute as a task B, it is dependent on A. Why task B is dependent on A? Can anybody tell why it is dependent? Why task B is dependent on task A? Because until unless you calculate the value C, you cannot perform this particular operation. That is D is equal to C plus A. In the similar context, we can say C is also dependent on A, right? Because the value of C need to be provided in order to execute D is equal to C minus A. So whatever thing we are doing inside this node is called as computation, okay, or we call this computing, right? But once a computation is done, you are providing that result to whom? To a particular node. Here also you are providing that solution to another node. So what happened here? Between two different nodes, you have communication, which in data structure term you are saying edge or you are saying link, right? So until unless you will supply that value, B and C is not going to execute, right? So this is called as a communication between two different nodes, right? So if you consider these nodes are nothing but the computer systems, it may be a personal computer, it may be a desktop, it may be a laptop, it may be any device. Then communication also can happen between two different devices in a network. So when you communicate between two different devices, we call that as a communication. Or with respect to time, we call that computation time and communication time. Right? So how faster we are going to execute the instruction? Okay, if you increase the speed capacity, okay, increase the processing power of a computer system, definitely speed, if you increase, definitely it will be there less time, we are going to get better result, right? We will get the result with a less amount of time. Sometimes when you write a big program, you are running in your laptop, it is not it is taking more time. But if you run the same thing in your institute computer like workstations or server, you have noticed that the result is coming very fast, right? Because the computation, okay, the device having much more powerful than the device is much more powerful than your laptop or desktop, right? So here we are talking about that is computing. We more focus on the computing rather than the communication, because maximum time, if you see, the computation is more in comparison to communication. Communication is there in cloud, but the problem is that we are more dominant towards the computing. Computing is dominating communication. That's why the subject name is called as cloud computing, not communication. That does not mean that communication is not important. Communication is important, but computing is more important than communication. For example, in order to compute a particular task, it requires, let's say, 10 hours of time. Okay, 10 hours of time. But in order to transfer this result, you require 2 minutes of time. That means computation is 10 hours, but communication is 2 minutes. So in that case, you can say computation is dominating the communication. Communication is negligible, right? That's why we refer cloud computing rather than the cloud communication. Now let us come to the definition given by ACM. I hope all of you are aware of ACM. ACM is a very popular publisher. It stands for Association for Computing Machinery. It is world's largest educational and scientific computing society. I hope some of you are also member of ACM. Okay. So ACM suggested one definition of computing in 2005. It is not a new definition. Okay. It is the way of defining computing. Okay. So they mentioned this definition in 2005, although this definition is too long, but I'll tell you some of the important words used in this definition. So they mentioned that we can define computing to mean in any goal-oriented activity. What is goal-oriented activity? Let us take a real-life application. One of the real is called weather forecasting. Right? Suppose I will ask you, what is the temperature of your place tomorrow? Okay, then you can type in Google. You can say it is showing that the sky may be cloudy, right? It may be a cloudy, or is it rain, right? Or no, the weather is clear. So how we are making this prediction? It is based upon the historical, right? Only historical data, based upon the situations, based upon the we are making a prediction that what is the temperature of a location in upcoming days, maybe 7 days, maybe 10 days, maybe you can say 1 month also, right? So if you want to do any goal oriented activity, this is also goal. Our goal is to predict the temperature, or the goal is to predict the humidity, or whether a particular location, whether it is there is rain or not. Such type of work if you want to do, we want to perform through some computation. Okay, it is benefiting from or creating computer. Not only for such for goal oriented activity, one computer system may not provide sufficient computation power. Right, when you deal with a very large application, the capacity of single computer system is not sufficient. So what you have to do? You have to combine the power of a set of computer system. Like if you go for your computer lab, in your computer lab you find 30 and 50 computer systems. So if I combine them, right? Let's say each and every computer system is having 2 TB of storage, and 30 computer system means it is 30 into 2, 60 TB of storage. Then one particular work I can do, but I cannot enhance a single computer storage device to 60 TB. It is not a cost effective solution. That's in that sense it is saying creating computer. So computing includes designing and building hardware and software system for a wide range of purposes. Not only for this purpose, right? If you see, before to cloud computing, we have another computing paradigm that is called as grid computing. Cloud computing is basically target for business, right? Many companies are offering cloud services, or many companies are heading towards the cloud. So more or less it is business related, right? But if you go for grid computing, which is there prior to the cluster computing, it is used to solve scientific engineering application like weather forecasting, like how to control malaria. For that also we have a project. There is another project called NFS. There is another project called ABC. Such type of scientific projects for that in order to provide the computation power to such project, we have grid computing. That's why it is not only supporting one particular goal-oriented activity, but a wide range of activity. Wherever you require computation, like in final year also some people are working in deep learning and machine learning, right? So you have seen when you are training a particular model, it takes more time. So there you need computation power. If a computation power is whatever is there in your computer system, that is not sufficient. That's why it is taking time. But in place of that, if you use a server, if you use a supercomputer, then your computation speed is going to be increased. So that faster you can train a particular model. That's why it is not limited to a particular application rather than any complex application where you need processing power, their computing will help you. So it is also saying processing, structuring, managing various kind of information, doing scientific studies using computer, making computer system behave intelligently, creating and using communication, entertainment media, finding, gathering information relevant to any particular purpose and so on. So like whenever you are traveling from one place to another place, you are listening the music, you are watching the videos. It is also provided from the cloud. It is services like you are using YouTube, you are using other medias. So there your service is provided through the cloud. So not only it is providing scientific engineering work, but also entertainment purpose also. Nowadays also if you go to cinema hall, there also everything is operated from some frequency. Something is loaded in the cloud and they are broadcasting that in each and every cinema hall. That purpose also we are using cloud, right? So computation is done in each and every place and cloud also there in each and every task whatever we are doing in our real life or any particular task we are engaged in our day-to-day life, you can find cloud. So the list is virtually endless. You cannot say that this particular problem computing is not there or the services is not provided from cloud. So the possibilities are very, very high or very, very a long list is there, right? So it is very vast. So this is the simple definition provided by computing, although it is a very big, you can say there is a very 5 6 line statements they have given, but this defines the word computing. Now, what actually we are going to discuss in today's class and upcoming classes. First, we will go for introduction to the cloud computing. There we will see the purpose of cloud computing, how it is different from other computing paradigm. Like before to the cloud computing paradigm, we have another paradigm that is called as grid. Prior to grid, we have another paradigm that is called as cluster. Right? Cluster, grid, and cloud. This is the history of different computing paradigm. So all these are belongs to our parallel and distributed family. Parallel and distributed family. Can anybody tell what is the difference between parallel and distributed? If you compare a parallel system with a distributed system, what is the similarity between these two systems? What is the differences between these systems? Especially differences, if you know, you can tell. What is the difference? Parallel and distributed system. Can anybody tell?
Parallel, we share the same memory, whereas in distributed, they have their own memories.
Exactly. Okay, that is one definitive difference between parallel system and distributed system. Like you see in your computer system, let us assume that your system is a multi-processor system. You have multiple processor, right? In your system, you have multiple processor. So she mentioned that you have the same memory, right? Irrespective of the system, you are using the same memory. So it is a parallel system, or sometimes we call parallel systems are tightly coupled system. Tightly coupled system. Tightly coupled system means if there are two processors, let's say P1 and P2, if a processor P1 is failed, okay, it is failed, it may be a hardware failure, it may be any software failure, anything, it is going to impact to the second processor because they are tightly coupled. Similarly, if there is a effect to P2, that is going to affect to P1. As they are using same memory, as they are using same clock cycle, so it is going to affect. But when you go for distributed system, they are called as loosely coupled system. They are called as loosely coupled system. So as the name suggests, distributed means they are not in a single place. So let's say one processor is here, another processor is here. So if there is something happen to the processor P1, it is not going to impact to P2. Okay. Or if something happened to P2, processor P2, if there is any failure, that is not going to impact the processor P1. So if you go for cluster, grid and cloud, you will find these systems are parallel system as well as distributed system. Like there are different computer system in different location. One may be at Mizoram, another may be at Meghalaya, another may be at Nagaland, right? Different systems are connected to each other, but they are having multiple processors. So they are distributed, but if you point to a particular location, there that particular system is having multiple processors. Like that, if you go for cluster computing, grid computing, and cloud computing, you will see these all are parallel distributed system. They belongs to parallel distributed family. Okay, the very first definition, if anybody will ask you what is the difference, you say these are belongs to parallel distributed family, but their underlying technology is different. The way they are adding node, the way they are working, that is different in the case of cluster, grid, and cloud. Okay, that we'll see in the overview of computing. Then we'll go for the cloud computing. There is a organization, you can say, that is called as National Institute of Standard Technology, NIST. That is there in US. So especially like when you purchase a particular product, you are looking into some hallmark or you are looking into some ISI mark, right? Such kind of things you are looking, right? So that shows that the product has some standard or fulfills the minimum requirements, right? If that mark is not there, then nobody is willing to purchase that particular item. Similarly, when a new technology is coming into the market, so these organizations or these you can say standard organizations, they are giving the definition. So cloud computing is defined by NIST, NIST. Similarly, cloud computing is also defined by IBM. Cloud computing is also divided by other organizations also. But as NIST is a very popular organization, so we are actually referring to the definition suggested by NIST. Then we'll see what are the properties, characteristics, and more importantly, what is the disadvantage of cloud. So when you want to learn a new technology, you try to focus on what are the drawbacks, right? Because anybody will ask you what is the lacuna in that particular technology. Obviously, you know what is the advantages of that particular technology, but you have to focus on what are the disadvantages as well. Then we'll discuss about the role of open standard. So if standardization is not followed, then you will find a difficulty in moving from one organization to another organization. So let us take a very small example. Suppose you visited a particular shopping mall X, right? That shopping mall offered you a specific offer where it will say if you add 5,000 rupees in our wallet, then you will get 6,000 rupees, and in these 6,000 rupees you can do shopping in our shopping mall X. Right? You have to only add 5,000. They'll give a bonus of 1,000, that is 6,000 total. It is there in your wallet, so you can do shopping of 6,000. Later point of time in your city, there is another company, that is Y, or another shopping mall coming to picture, and now it is providing better uh, product or better things comparison to X, right? So if you want to migrate from X to Y, it will be difficult for you, because this wallet balance, whatever you have, that is not going to be transferred to the Y, right? So before moving Y, or you have decided to move Y, then you have to think that what about my wallet amount? But if there is any standardization is there, the wallet which is applicable for X, that is also there for Y, then you need not bother about that, right? Whether it is X shopping mall or Y shopping mall. Today you can shop with X, tomorrow you can shop with Y, right? So that is the need of standard. If standard is not followed, then if you are habituated with X, it is difficult for you to move to Y. That we'll discuss. Then we'll go for the cloud computing architecture. Before going to the cloud computing architecture, I hope you know about John von Neumann architecture. Are you aware of John von Neumann architecture? Can anybody say what is John von Neumann architecture? Anyone? Are you aware of John von Neumann architecture? Have you studied computer organization and architecture?
Yes, sir. We have studied that in COX.
Okay. But have you studied John von Neumann architecture?
Yes, sir. Two architectures we studied, one Newman and Harvard architecture. I think what I
Yeah.
remember.
Okay. Why I'm saying this architecture? Before going for this cloud computing architecture, you should know what are the other architecture available for computer system. Here it is cloud computing, but computer system. You can recall, I'll tell you 1 minute related to the John von Neumann architecture. If you go for this von Neumann architecture, it is a very simple architecture, which the present day's computer also followed this particular architecture. What we have in this architecture, we have input devices. Okay, I/P stands for input. We have input device. Similarly, we have output device. Then in between input and output device, you have CPU, right? This is central processing unit. Through input device, you are giving input to CPU, and through output device, you are getting the output, right? And what is there in the CPU? CPU has two important units. One is called as control unit, that is called as CU. Another unit is called as ALU, that is called as arithmetic logic unit. And there is another unit we have where we store the data, that is called as memory unit. Okay, and memory unit is connected to the CPU and ALU bidirectional, right? Means memory to CPU is you can communicate, and CPU to memory also you can connect, just like read and write type of instructions. So this is a simple architecture which is very famous. You have seen in computer organization. Now here we are talking about cloud computing architecture. How cloud computing looks like from a user perspective, another is called as cloud service provider perspective. Who is providing us cloud? A cloud service provider. Like if I ask you where you purchase vegetable, So there should be some provider, right? X provider, Y provider, where you purchase your goods and services. Some provider is providing. Similarly, cloud services you can get from different provider. These providers are nothing but Amazon is a very popular cloud service provider. Google is another popular cloud service provider. Okay. Similarly, IBM is a provider. Okay. You can say uh, Microsoft is a cloud service provider. Like that, there are long list is there, right? They are the provider. So they are providing services to whom? A user, right? User is getting services from these cloud service provider by requesting some service. User has requested something to the cloud service provider, and cloud service provider has provided the services to the user, right? So if you look into user perspective, how the cloud computing architecture look like, or on the other hand, if you look into CSP perspective, cloud service provider perspective, how actually the architecture look like, that we'll discuss in cloud computing architecture, which we call as cloud computing stack. Like data structure, you have studied stack, right? What is stack? You can see, suppose you are inserting one element into the stack, another element you want to push into the stack, so it is placed just above it. Similarly, whenever you go for cloud computing architecture, you will find there are number of layers. Like if you have studied computer network, then you are aware of the 7-layer model, which we call as OSI ISO reference model, right? So there also we have 7 layers. One layer is on top of another layer, right? That's why it is called as cloud computing stack. So this may be one layer, this may be another layer, this may be another layer. The responsibility of each and every layer is different. So they are coordinating each other. These layers are coordinating each other to provide services to the user. Okay, that we'll discuss in the cloud computing stack. Then we'll discuss about service model. There are different types of cloud we have. When you talk about different types, on what basis you are saying they are different? So in cloud computing term, they are different with respect to the service, the type of service they are providing, and with respect to deployment. Deployment means location, where you want to put the cloud. They are divided into different types. Like when we go for a particular restaurant or hotel, it is mentioned that self-service. Okay, what do you mean by self-service? You already visited the hotel. Can anyone tell what do you mean by self-service?
Sir, they provide the services based upon on their own. Like they don't use any other platforms or uh, thing
Yeah,
to provide the
you, you
service.
you told more about cloud, right? It is not related to a restaurant. In restaurant, self-service means you have to pay the amount first, right? You have to collect the bill. You have to go a particular counter. You have to submit that bill. They'll give you the food, and you have to take the food, and you have to eat again. You have to put in the dustbin. There is no person to help you, right? That too mean by self-service. But your what you say that is more related to the cloud, right? Similarly, cloud case also, like this is called a self-service, but some restaurant we usually go, okay, and there is no need to pay the amount first, right? They will come, waiter will come, they will ask for the items, right? We will choose some item and later point of time. So there are different types of services we have. Similarly, if you look into different type of services provided by cloud, based upon the services, they are divided into 3 type of services. One is called as infrastructure as a service. Next one is called as platform as a service. Third one is called as software as a service. Again, if you go for this protocol stack or cloud computing stack, you will find infrastructure as a service in the bottom, right? Always remember, any architecture, if you go, always the hardware part is there in the bottom. Any protocol stack, you will find hardware things are in bottom, software things are in top, right? On top of infrastructure, we have platform. On top of platform, we have software. So the acronym which used for infrastructure is called IaaS. Then another is called as platform as a service, that is PaaS, the acronym. And for software as a service, the acronym used is SaaS. So these are the three basic services of the cloud. But later point of time, people come up with their own service. Like those people who are working in the field of healthcare, hospital management system, they call that as a healthcare as a service. Those people who worked in sensor, they come up with a solution that they says sensor as a service. Although the acronym looks same, okay, but the abbreviation, the full form is different, right? So later point of time, people represent this thing as anything or everything can be a service. Like people comes up with the security as a service, privacy as a service, right? That's why it is represented as XaaS, that is called as everything as a service or anything as a service, right? So this is the basic related to the cloud computing architecture, how they are present in different layers, right, or in a state format, and what is the service, what are the service models, and what are the deployment models. Now coming to another one is that is called as service management in the cloud. Like suppose you want to purchase a air conditioner, right? You have visited a shopping mall. You want to purchase a air conditioner. Okay. So with air conditioner, what things they are giving to us? Can anybody tell? They will give outlet other things, but what papers are they are giving with air condition? If you want to purchase a air condition from anywhere, right, or let it be from online shopping website, e-commerce sites like Amazon, Flipkart, and other websites, right? So what documentation they are doing when you purchase a air condition? Can anybody tell? Any item you want to purchase from market, what extra thing they are giving, what paperwork they are giving?
Warranty.
Exactly. You mentioned a proper term that is called as warranty. Or sometimes we say also guarantee card, right? Guarantee card is given with the bill, right? What is there in the warranty card? What is there in the warranty card?
Some do's and don't, and also
Exactly.
um, like how
Some terms
long.
and condition.
Yeah, yeah,
Okay,
basically
some
terms
terms
and
and conditions are there, right? But as a user, as a normal user, you hardly read what is mentioned in that particular document. Right? The terms and condition is there, but we are not reading that one, right? Similarly, whenever we are installing a particular software, it is asking us to read and understand the agreement and accept it. But what we are doing, without reading, we simply select, we accept it, then the software is installed, because we know that once if I will not agree with the terms and conditions, then the software is not going to be installed. Similarly, whenever you want some service from cloud, a user and your cloud service provider, right? This is, we talked about a normal marketplace, but when you go for cloud marketplace where user has to done some agreement with the cloud service provider. If anybody wants to provide service like warranty card, it is mentioned that let's say these parts, if it is damaged, then within let's say 12 months, then it will be given by that particular company, right? So within 12 months, if there is something happen, then you directly claim, then they are coming to your home or installation place and they repair that without any cost, right? But what happen if they are not going to repair that? What you will do? If whatever mentioned in the warranty or guarantee card, if it is not followed, then as a user, what you can do?
We have to pay for that service.
Who will pay for the service? User?
We user, yes, sir.
No, user will not pay. Why you will pay? It is already in the warranty, right? It is already there in a particular
Okay,
warranty
sir.
period.
Okay,
So
sir. Yeah, I thought.
yeah, definitely. If it is exceeding 12 months, whatever you are saying, that is, I am agree with you that you have to pay for the service, right? But if it is within 12 months, if it is not there, then you will lodge a complaint, right? You will simply lodge a complaint that in my warranty card, it is mentioned that after 12 months, okay, within 12 months, whatever issues or problems happen, that will be addressed by the company. But now the company is not providing that service, right? Similarly, when you go to cloud environment, user and cloud service provider signing in a particular document. It is not a physical document, right? It is not a physical document. They are agreeing with some terms and condition. We call that as a service level agreement. You can see here the term is called a service level agreement. What is there in the service level agreement? It is a detailed document related to what kind of services you need. It is a document which specifies what is the downtime, what is the uptime, what is the reliability, what is the availability of your services. So if any later point of time, if the service is not provided by your cloud service provider, like I mentioned here, it is there within 12 months, but the services is not provided. Okay, within 12 months you are claiming for some service, it is not provided, then you can lodge a complaint. Okay, once you lodge a complaint, what will happen? The SLA document is going to be reviewed, right? With a certain terms condition, your provider as well as you agreed upon, right? So if I revisit the service level agreement, then I will come to know whether service provider is correct or the service consumer is correct. So if service consumer is correct and service provider is not providing the service, then provider has to pay some amount to the consumer, which we call as service level agreement violation cost, right? Like sometimes also in some article or some news channel, you are getting news, somebody has filed complaint against X company, and finally the judgment came that X company has to pay this much amount to that particular user. That's why the terms and condition is maintained in a particular document or written in a particular document, that is called as SLA document. Or if you have studied software engineering also, you know, while we are developing a particular software, we have a document that is called as SRS document, which is called as software requirement specification document. It is also a concrete document between the user and the provider, right? Any dispute is coming in future, this document is going to be the review. Okay, the next topic we are going to discuss about the cloud economics, right? It is also a very important topic. Like, you know, in each and every company, we have a position that is called as CTO. What is the full form of CTO? Can anybody guess? In a company, when you join a company, you will see there is a post called CTO. What is the full form of CTO? You know CEO, right? Chief Executive Officer, right? What is CTO?
So Chief Technical Officer.
Chief Technical Officer, right? So suppose you have joined a particular company, okay, and in that company has recruited you for this particular post, right? CTO post, right? Now you have two plans. One is called as Plan A, another is called as Plan B. What is Plan A says? Plan A says that everything is going to be managed by your own company, which we call as in-house servers. Anything you need that should be maintained by your in-house servers. Plan B says that why to worry, why to manage these servers in our campus, why not we move to cloud? let the cloud provider manages the servers. So you have two plan A and plan B. So you as a CTO, you have to decide whether to take plan A and plan B. Which one is beneficial for you? So you have to consider all type of cost, right? Like basically we have two type of cost. One is called as fixed cost, another is called as variable cost. Like we purchase a computer system, it is a fixed cost, right? But in order to run this computer system day by day, you require some amount. Let it be for maintenance, let it for electricity, let it be for other things related to the computer system. So you have to see whether plan A is beneficial for your company or plan B is beneficial for your company for a particular period. Let's say you want to assume that if both plan you have to examine with a 3 year span, 3 year period. Within 3 year period, you have to observe whether to go for in-house server or to go for cloud server based upon your company's value and benefits and other things, profit and other things you have to decide. That comes under the concept of cloud economics, right? The last part that is called is we'll discuss about the resource management in the cloud, right? You know there are a huge amount of resources we have, right? Cloud service providers are maintaining these resources. So whenever a client requests for a particular service, how the service is provided by the cloud service provider, and basically how these resources are managed by your cloud service provider. The way you are maintaining the in-house server, the same way you can maintain cloud servers, right? The way we are maintaining our in-house server, the same way you can maintain the cloud server. But the number of customers are very huge in the case of cloud service provider. But in-house server, it is limited to your company. So we need to know that how CSPs manages this thing so that irrespective of the load, right, they can manage the things in their infrastructure, right? So this is the overview which we are going to discuss. Okay. Next, we will discuss about the data management in the cloud computing. Data is nothing but storage. Like when I asked the question, Isa especially mentioned about the storage, right? So when we talk about the storage, then we have to see that what is the amount of storage available, whether it is sufficient or not, whether it is finite or infinite, whether we can increase the infrastructure into a greater extent or not. For example, one of the example I'll tell you here, all of us are using Gmail. Most of us are using Gmail or Google services. So you know how much space is given by Google for each and every account. What is the space provided by Google per account?
15.
Yeah, the answer is 15 GB, right? But if you see the emails provided by your institute, right? You have an institutional email ID, right? We have also our institute email ID, right? If you go for your institute email ID, until unless your admin has restricted, you will not get such type of limit, right? So whether it is 15 GB or it is 15 TB, if there is no limit from your admin side, then you can expand, which we call as scalability. Scalability means you can increase to any number, and later point of time, if there is no requirement, you can reduce to a small number also, right? Similarly, database also can be maintained in the cloud. You can do also data processing by the help of the cloud. So cloud not only provides services related to the computation, but also provides services related to storage. And irrespective of the technology, you will see security plays a very important role. At any point of time, security should not be leaked. If security is leaked, then nobody will rely on that particular technology, right or not? So there are different type of security we have. We have infrastructure security, we have data security, we have platform security, we have software security, And there are other terms related to security we'll discuss under the cloud security, like trust and opinion. Trust and opinion and reputation. Like whether you can trust a particular site or not. Nowadays also we are getting a lot of ads, right? Advertisements. It is showing you can purchase this item with less cost. Sometimes we are very attractive, we are that offer is very attractive. So we are heading towards that particular offer, right? But later point of time we come to know that that website is fake, right? So when we are talking about the trust, whether you trust a particular person or particular website or not, that is your personal opinion, right? That is completely your personal opinion. But what about reputation? Suppose I'll tell you, uh, what about Amazon? Whether Amazon is a good provider or not. So it is not your personal opinion. Reputation comes from public opinion. If most of the people are happy, like whenever you purchase a particular item, you are looking into the rating. So if maximum people are happy with that item, you assume that you will be also happy. So trust and reputations, although these terms are very close to each other, but trust always says your personal opinion. Today you may not trust a particular thing, tomorrow you may trust, right? It will vary with respect to over a period of time, but reputation will not vary. Reputation is purely an public opinion. Then we'll see the case study of open source commercial cloud. I'll show you also some of the demos and hands-on related to the cloud so that at least you should know what kind of practicals you can do by the help of cloud computing. And also I'll discuss about some of the simulator. Not only cloud simulator, I'll tell you also some fog simulators also. Fog is another paradigm. So you should aware of these simulators. Simulators will give you a infrastructure or a virtual environment in which you can work. It is not an actual environment, right? That's why we call it a simulation. But when we talk about experimentation, experimentation means you have to deal with the real devices. It is not a virtual environment, it is an actual environment, real environment. Okay. And we'll discuss about some of the research trends of cloud computing and fog computing. Okay, let us take a 5 minutes break. Then we'll discuss about the trends in computing. Okay, if you have any question, you can ask before going for break. Anyone having any question till now?
No, sir.
Okay, so the now time is 4:04. So we'll again resume our class at 4:10. Is it fine?
Yes, sir.
Okay, thank you. Am I audible?
Yes, sir.
Yes, sir.
Okay, thank you. So let us resume our discussion. So we'll start with trends in computing. Already I introduced the term computing, and I also told you that cloud computing is not only the first computing paradigm, but before cloud computing also you can see here there are different type of computing we had. And not only cloud computing is the latest computing, after cloud computing also there are so other computing paradigms are there that also I'll highlight here. One is called as fog computing, another is called as osmotic computing. Okay, these are the different computings are there. Only you should know the overall about this thing. I don't want to tell you in detail. So let us start with the distributed computing. So you know that parallel computing and distributed computings, they are different from each other, that we already discussed. I told you in distributed computing, you have you can say that the memory is not with the system, right? You don't have local memory, right? Like sorry, each and every systems are having the local memory, right? But in if you go for parallel computing paradigm, then we have a shared memory. And also we have seen parallel computings are tightly coupled system, and distributed computings are loosely coupled system. So distributed means it should not be placed in a single place. It will be placed in different location. Like one of the example you can see our internet server. Our internet servers are placed in different part of the world, and you can see from the birth of internet to till date, there are several failures happen, but it is not affected to the internet what we are getting in our system, because they are present in the different place. So if even if there is a natural calamity happen in different part, it is not going to collapse the whole system. So that is the purpose of going for the distributed system. So after distributed system, we have actually cluster computing system. So cluster computing system, as you know, if you go for a single computer system, our hard disk size may be 2 TB, right? And our RAM size may be 4 GB, right? But in order to run any big application, like I told you, goal-oriented application, or I can say scientific engineering application, you require more space, and that space cannot be provided. That power, processing power, cannot be provided by a computer system. So what we can do, instead of increasing the hardware part of your system, like 2 TB to let's say 4 TB, or 4 GB to let's say 8 GB, it is better to uh, go for different systems, right? Instead of increasing the hardware resources of a single system, you can combine one or more system. So based upon that, we have cluster computing system, grid computing systems, or we have cloud computing system. So what I can say, in a computer lab, if 30 computer systems are there, each and every computer system, they are connected through local area networks, right? And out of these 30 computer system, I can say 29 computer systems are clients, and one computer system is server, right? So what, in what way they are going to process the application? The server has to receive the application and divide that particular application into small chunk, right? Like if a module is there, you can divide that module into sub module. Or if you take an example, suppose you want to add 1 to 100, right? So once this particular task 1 to 100 you want to add, once this task is received by your server, what your server does, it has divided this addition into 10 different parts. For example, it will say the first part is 1 plus 2 plus 3 up to 10. Another part may be 11 plus 12 plus 13 plus up to it is 20. 21 plus 22 plus 23 up to 30. Like that, it will be 91 plus 92 plus 93 up to 100. Okay, so we have divided the same task into 10 different tasks. If I assign these 10 different tasks to 10 different computer systems, then the computational requirement, the storage requirement is not required. That much requirement is not there. An individual computer system can execute this computation and return the result to again to the server. Server will consolidate by adding all these 10 different sums and return the result to the user. So if this computation, assume that this computation is not sufficient, like if a computer system can do only addition of 10 numbers, like in calculator also, in our childhood we have seen, if you want to add more numbers, then after certain time it is not able to add. So what you can do, you can divide that task which is convenient to a particular computer system and decompose the task and given each piece to each and every client. Okay, one piece to one client, and later point of time you can combine it and return the result, right? So when you talk about such system, if these computer systems are having same configuration or they are having same characteristics, same architecture, we call this system as cluster computing system. Like you can say these computer systems are having same operating system, like they are having Windows operating system or Linux operating system, or these computer systems are having same processor or you can say same amount of storage, then we can call that system as a cluster computing system. But when you go beyond a particular limit, like if I ask you to collect 30 computer system of the same configuration, then you can collect it, right? If you go for a computer lab, you can collect it, right? But when I talk about, let's say, 1,000 computers, million computers, billion number of computer, it is not possible to find these many computer systems are having same architecture, same configuration, right or not? Like you can check your configuration with your friend's configuration. It is different, right? But both of us, both of you have purchased the same model at the same time. They are there, then they are same. But over a period of time, the configurations are changed. Okay. If you want to integrate such system where there is a different architectures are there, we call that as a grid computing system. So cluster computing case, you will find similarity. Grid computing case, you will find a dissimilarity of the system. So if two computer systems are having same configuration, technical term we call they are homogeneous computer system, or we can say homogeneous nodes. But when two computer systems are having dissimilar configuration, they are not having the same characteristics, then we call these computer systems are called as heterogeneous computer system. So in real world, you can see the systems are actually heterogeneous. They are not homogeneous, right? We can combine as much as computer system is possible. Like if you talk about NITs, we have 31 NITs, right? 30 NIT or 31 NITs. If all NITs will contribute together, you can build a grid computing system. Okay, but you cannot assure that they are having the same architecture. So in network also, you will find the nodes are heterogeneous in nature. They are not in homogeneous in nature. In that way, grid and cluster computings are different from each other. Is it clear? The difference between cluster and grid?
Sir.
Yeah. So the next type of system is called as utility computing system. I'll tell you these terms more detail in the upcoming classes. Just I'm introducing these terms so that you will feel comfortable while I'll explain those terms. Utility computing systems, like you see about our electricity. You know how our electricity system works, right? You are getting electricity bill. So based upon your consumption, you are getting your electricity bill. Like if you go for winter season, right? It is extremely cold. We are not using air condition. We are not using fan uh, and other cooling devices, right? So what happen? Our electricity bill is less. But when you go for summer season, let's say in summer season we need air condition, we need fan. Okay, if we have multiple fans in a particular room, also we are using that. So our electricity bill is high. So what this example shows? This example shows that it varies upon the price, varies upon or the bill depends upon your usage. So electricity is considered as an utility. If you use more, you have to pay more. If you use less, you will pay less. Not only electricity, if you go for LEDs telephone, okay, or if anybody is using nowadays also any mobile provider where you are paying the amount per minute basis. Nowadays we are using 84 days plan, right? Irrespective of the provider. But LEDs, suppose you recharge 100 rupees, then they are giving 100 units. 100 units means 100 minutes. So if you talk for 0.00001, right? Then also 1 unit is deducted. Or if you talk for 0.00059, also 1 unit is deducted. So if you talk more with your friends, your family, right? Then you can see the amount of bill coming it is more. But if number of calls are less, definitely the units are not consumed. That's why your bill is less, right? So telephone can also be considered as an utility, right? Can anybody tell what other utilities we are using in our day-to-day life apart from this electricity and telephone?
Water bills?
Exactly. Nowadays, metro cities, we municipality is giving water. So there is a water meter. Most of the places of India, it is not implemented, but metro cities, they have implemented this thing. So if you consume 50 liter in morning, again 50 liter in afternoon, right? You have to pay according to the consumption, right? It is not unlimited up to certain period of time. Like electricity also, let's say up to 50 units, you have to pay. Let's say for example, I am saying it is 100 rupees. But once you exceed 50 units, they are charging more. Once we exceed 100 units, they are charging more and more, right? When it exceeds 200, it is very high, right? So water is also is a utility, right? If you use more, then definitely you have to pay more. Any other utility you are using in your day-to-day life?
Gas.
Exactly. The last one is called as gas, right? We are now piped gas is also there. Like if you are using phone pay, right, or paytm, you can see there is a piped gas is there, although it is not implemented in all parts of our country, right? But gas also based upon our usage. If you talk about the cylinder also, not only the piped gas, cylinder case also, if it is more, right? If you use more, then definitely you have to you are consuming more, right? As you are consuming more, you have to pay more, right? If it is consumption is less, then you have to pay less. So these four are the essential utility in our day-to-day life. So one of the professor who has done a numerous work in the field of cloud computing, his name is Professor Rajkumar Bhuya. Okay, you can Google it. His name is very active researcher in the field of cloud computing, who is also associated with our department of CSE NIT Warangal. So he mentioned that computing is called as the fifth utility of the human life. Okay, like we consider electricity is in one utility, telephone is one utility, water is one utility, fourth is utility, fourth gas is an utility. So computing is the fifth utility system, right? So like nowadays also, government always encourages students, faculty members to go for the startup companies, because if you start a new company, you can give jobs to number of people, right? So when you go for a startup company, suppose you don't have a sufficient amount, right? In order to go for a startup company, you need a workspace, you need some computer systems, you need some people, right? For that you have to incur some cost, right? So initial level, it is very difficult for you to run your company. So when we are talking about computing and computer resources, why not use these computer resources which are provided by different cloud service provider, right? Different cloud service provider like Amazon, I mentioned about Google. So they are providing you the computation resources, or you have created one website, nice website, but you want to host this particular website, or you want to deploy this particular website, so you need a server. But purchasing a server is more costly for us as an individual user. So why can't we purchase one server from cloud and host our uh, website there, right? So that's why it is called as the fifth utility of the system. Utility simply meaning is that the usage. If your usage is more, you have to pay more. If your usage is less, you have to pay less. So all these computing's advantages you can find in cloud. It is not a new term, you can say, as I already mentioned. Whatever technologies are there in parallel distributed computing, cluster, grid. In fact, grid computing is said to be the backbone of cloud computing. As we are meant for a business purpose, but if you go for the background, we have grid computing, right? So these are the different trends of computing. As I mentioned, there is another computing paradigm nowadays popular, that is called as fog computing, right? What is fog? Like you can see, if you go to our nature, in between ground and cloud, right? Ground and cloud. What we have? Fog, right? Like especially in the winter season, we are able to see the fog. So fog is an intermediate layer between ground and cloud. So in technical term, this ground is called as IoT devices. What is IoT devices? IoT devices are nothing but different kind of sensors, different kind of actuators. Like whenever you are going to airport and other places, you have seen for water taps, we have sensors. We have to dry our hand. For that also we have sensors. We have various kind of actuators like motor is an actuator. The different actuators are also there. So always pushing the data. Suppose some sensor is generating the data, like you have deployed a sensor in your institute campus, and you want to observe this sense. The sensor will help you to calculate the humidity. Or you have deployed another sensor which is capable to calculate the temperature of your institute in a particular location. Then once this data is generated, where you are going to store this particular data? Sensor work is to collect the data. Once you collect the data, where you are going to store? Can anybody answer? Sensor can collect the data, but sensor is not capable to store huge amount of data, right? So sensor need to push this data somewhere. Where actually we are going to store this data? Yeah. Where we are actually storing, Neeraj?
Sir, in cloud
Ex-
database.
Exactly. Cloud database, or you have a base station kind of thing where you can store the data. But when you push this data to the cloud, cloud is very far away from our ground or not in real situation also. Although it's a technology term, but if you see IoT and cloud, there is a huge difference. So if the distance is more, then the communication is also more, right? The distance is more, definitely communication time is more. Again, sometimes also I need to give some instruction to these IoT devices after processing of this data. Then again, cloud will communicate to the IoT devices. Then also it is more. So in order to avoid this delay, what we have introduced another layer that is called as fog layer. But fog is not a replacement of cloud. Note down this important point. Fog is not replacing the cloud, rather than it is just like a complementary, right? So if the computation can be done in fog or can be stored in fog, we'll push to fog. But if it is not capable to process, we'll ultimately go to the cloud only. As fog is near to the ground, we push all the things to the fog first. If fog is incapable, then we'll go to the cloud. But if fog is capable, our communication time is reduced, right? So that's why there is another popular paradigm that is called as fog computing. Similarly, people are come up with another computing paradigm that is called as edge computing. We have routers, we have gateways. They are also having some processing power. These are the network devices that we are using. You studied in network. So there also you can push your data. That is called as edge computing. And the latest computing is another computing which is called as osmotic computing, which says that when to push the data to the cloud, when to push the data to fog or edge, how to push, this will be decided by the osmotic computing. It is bidirectional. Sometimes fog also needs the help of IoT devices. Not only IoT devices will help always push the data to the fog. Sometimes fog devices also require some resources from the IoT. Similarly, sometimes cloud also needs help from the fog. Not it is always from fog to cloud. It is also from cloud to fog. Such type of things you will see in the osmotic computing paradigm, which is another form of computing. Okay, like that there are several computing paradigms are there, but related to the cloud we have distributed grid, cluster, utility, and fog computing. These things we'll discuss as a part of this particular course. So let us start the first one, that is called as distributed computing, right? So we have already discussed distributed computing. So distributed computing is different from a centralized computing. Centralized computing means it is located in a single place. Distributed computing means it is present different places, not in a single place. Like here you can see I have three terminals. I can say terminal 1, terminal 2, terminal 3. Right? Three terminals. Terminal means computer systems. They are connected to a server. We call that as a main computer. So terminal 1, if he needs that particular terminal, requires some resource, it has to make a request to this mainframe computer. Once it will send a request, the server has to reply to this particular terminal. Right? Similarly, if T2 needs some resources, it has to send a request to server, and server has to reply something to T2. Like that for T3, like that any number of terminals can be connected to the server. The overall objective of centralized computing is that this mainframe computer is more powerful, or the server is more powerful than the terminal. And terminal and servers are having a relationship of, they are following reply and request reply way to get the requirement and provide the solution to that particular requirement. But when you go for distributed computing, you can see here, like this is a workstation, this may be a terminal, this may be your personal computer systems. They are connected through the network links, and they are not present in one location. Let's say this particular system is there in United States of America. This particular system is there in our country. Another system is there in Singapore, right? So if there is something happened to the Singapore server, it is not going to affect USA and India. Okay. our internet system is also an example of your distributed system. It is not located in the same place, right? So if you go for previous computing mechanism like our early days personal computers, if you look into, they are having only one processor. But when you talk about a multi-processor system, we have more than one processor. Obviously, you can do more work in multi-processor system than a single processor system. So it may be a centralized computer, it may be a distributed computer. I'm not saying only in the centralized computer system you have single processor or multiple processor. Anywhere you may have single processor, anywhere you can have multiple processor, right? But you can see the dependency here. There is a master-slave relationship here, right? Master is more powerful than slave. But here it is not a master-slave relationship, because here each and every system is not dependent on each other. They are independent, right? So uniprocessor computing can be called as your centralized computing system, but not limited to. Sometimes multiprocessor systems may be there in a particular server. That can be also considered as a centralized computing system. So distributed computing is a field of computing science that studies the distributed system. Okay, it studies about a distributed system, and distributed computing is uses distributed system to solve computational problem. One of the example I already mentioned you, like if you want to add 1 to 100, let us divide that into 10 different friends. Your first friend will calculate from 1 to 10, second friend will calculate from 11 to 20, and so on, so that in a faster way you can compute the addition of first 100 numbers. Okay, for a simple calculation I am saying you, although there are different formulas are there to calculate sum of a set of numbers. So if you go for Wikipedia, the definition of distributed system is there are several autonomous computational entities. Autonomous means, you know, sometimes we say autonomous institute. Our institutes are autonomous institutes because we are not dependent on other institutes. Similarly, here the computer systems participated in the distributed system. They are not dependent on each other. That's why we call this a autonomous system. And also somebody has already mentioned also that here each and every one is having its local memory. Like this is a distributed system, it is having its local memory. This is another place we have a system with its local memory, and is another place where we have a local memory. Okay, we have our own local memory. What is there in this particular memory, it is not known to this particular processor. And whatever available in this particular memory, it is not known to this particular processor. That's why we call it a local memory. But if it is a shared memory, if something is shared between multiple people, anybody can see. Like if I share a particular video, right, then anybody can see. Right? That is in a shared space. Right? Anybody can create an instance and see that particular video. So here, these entities, this is a system, this is another system, this is another system, right? These entities are communicated with each other by message passing mechanism. The way they are communicating each other is called as message passing. Okay, like here you can see, if we talk about 3 different systems, they are connected like this. But when you talk about 100 different systems, do you think each and every computer systems are connected to each other? May not be. Right? Why? Because let's say there are multiple systems are there. It may happen that they are connected like this. Still they are connected, right? Not necessarily that each and every node is going to connect with the other nodes. Right? Like here you can see, like in network you have studied something called as a mesh topology. Right? In mesh topology, one node has to be connected to another node with a dedicated link. But here you can see you can reach from this particular system to this system, but not directly, but indirectly. You may consider this node as your intermediate node, or these two nodes are your intermediate node to reach here. So in that way, distributed system is organized, not in they are reachable to each other directly. So you can see we need also some thing related to the operating system which we have studied. Like processors communicate with each other. These are the different processors, right? We have considered three different processors. They communicate with each other through various communication lines. So what do you mean by these lines? Like, you know, in computer systems, we have CPU. CPU is connected to memory. CPU is connected to input. CPU is connected to the output. So they are nothing but your high-speed buses or telephone lines. If there are, like if you go for our local telephone lines also, we have poles, right? And through lines we are connecting to our telephone, right? Similarly, there are different types of you can say interconnection. You can say different type of buses are there. Different types of lines are there. One line may be capable to transfer 1 Gbps of information. On the other hand, another can be transfer only 100 MB of informations, right? So they are different from each other. Now, if you see some of the examples of your distributed system, here you will see internet is a true example of our distributed system. Our ATM machines, they are distributed system. For example, suppose you have a account in X bank, right? And X bank has issued two ATM card, right? ATM card 1 and ATM card 2. ATM card 1 is with you, ATM card 2 with your father, right? But you are operating the same account X. Suppose X account is having 1000 rupees balance and you have withdrawn 300 rupees. And after a fraction of second, your father has withdrawn 400 rupees. So both transaction is going to be the both places the same information will be there. Once you deduct the 300, the balance will be updated to 700. And within a fraction of second also, if you are operating an ATM from different place, then also that particular transaction is going to be reflected. That is also an example of a distributed system, right? If it is not there, then it is inconsistency, right? It is inconsistency. Different part, many people can operate, right? And they can misutilize the amount, right? Although you don't have sufficient amount, they can withdraw it if it is not maintained in a distributed fashion. Like intranet, in our hostel we have intranets, right? We can able to download a movie, we can download a software, we can download a large file. That is also an example of distributed system. So computing landscape will soon consist of ubiquitous network connected devices. Ubiquitous means anywhere. Like you can access to internet through any devices, whether it is a simple smartphone or it is a high amount smartphone, or it is a laptop or it is a desktop. It is maybe a server, it may be a workstation, or it may be a supercomputer. Anywhere you can connect to the services, anywhere you can do the computation, anywhere you can access the internet, right? So that's why it is there in everywhere, and they are connected through the network devices. Now, these are actually the computers in a distributed system. We have workstation. Okay, workstations are generally more powerful than a simple PC. Like you can say in workstation case, we have 32 GB of RAM, or you can say 64 GB of RAM, and it is having 4 TB of hard disk or 8 TB of hard disk, right? So it is a computer system only, but its computational capacity, storage capacity is more. So computers used by end users to perform the computing. Now we have server systems, right? Server has more capable, right? So they are different from each other based upon the different hardware requirements, right? Or be based upon their communication, how faster they are, right? So in that way, you can different one computer system with another one. Like here, you can see in the server system, they are the computers which provide resources and services. Similarly, we have personal assistant devices. Okay, we have handheld devices, right? Like we have tablet. It is also an handheld devices through which you can connect to the internet. So handheld computers connected to the system via a wireless communication link through hotspot or through Wi-Fi or through Bluetooth also we can connect multiple devices into a single system. Okay, now come to different properties of distributed computing, because the same properties you will find in the case of cloud computing, because cloud computing comes under the family of the distributed computing. First one is called as fault tolerance. Fault tolerance says that even if there is a fault in your system, it is not going to affect the performance of the system, right? If you imagine a distributed system, okay, in a particular distributed system, as it is a system, right, or it is a machine, so failure is obvious one. Right? There may be a hardware failure, there may be a software failure, there may be a communication failure. It is the obvious one. So one or more node they can fail over a period of time, but it should not affect the performance of the whole system. Then we can say this entire system is called as fault tolerant system. Again, you may ask how many faults I can tolerate. You cannot go for any number of fault you can tolerate in the system, but up to a certain fault you can tolerate, and the whole system can work fine without that failed node. It is not going to impact the performance. So over a period of time, you need to check the status of each and every node. So in network also we have studied that is I am alive message, or we are saying ping message, right? These messages are used to know that whether the nodes are connected with each other or not, right? Come to the second property, each node play a partial role. Like I told you, addition of 1 to 100, you are divided into 10 different parts. You assign each and every part to one computer system. So they play a partial role. Okay. So they execute them and return this result to the server, right? If it is a client server mechanism, client has to execute it and return this one into the server. Or if it is a peer-to-peer system where each and every nodes are having same, you can say same power, distributed computing systems. It is a peer-to-peer system, right? So in that case, once they are computing, one node has to consolidate everything. So each computer has only a limited, incomplete view of the system. Suppose a node is given with the addition of 1 plus 2 plus up to 10. So this node is not willing to know or bother about who is computing 11 plus 12 plus up to 20. Okay, is not going to bother, right? No need to also know about this system. That's why for this particular system, the entire system is an incomplete view. Okay, if it is a complete view, then again security issues will come, right? And each computer may know only one part of the input. It is not willing to know other part of the input, or it is not dependent on other aspect. Another property is called as resource sharing. Why they are connected to each other? For a goal-oriented activity. Weather forecasting, it is required to each and every individual. It is a societal need. It is a global need. That's why each user can share the processing power and storage with them, right? With other users. Today you need more computation, I'll help you. by sharing my computer resources. Tomorrow, you need some thing to execute, or you want to deal with a scientific engineering application, you need computation power, you need storage, I'll help you. Okay, like that, multiple computers are making are together to provide the services. That's why it is called as resource sharing. Another one is called as load sharing. Load sharing there says that one should not be overloaded. On the other hand, another should not be underloaded. Right? Sometimes it happens when you see network traffic, right? Especially e-commerce sites like Flipkart and Amazon. Sometimes they are getting more requests. So they have to share these loads among different servers. If one server is going to address everything, then the server is going to be collapsed. So dispatching several tasks to each node can help share loading to the whole system. So for this in cloud, we have a load balancer. So your request when a client want to get a service and the service is there in the cloud, so it will reach to the load balancer. Load balancer has to decide whether to redirect this request to server 1 or server 2 or server 3. So it is responsible to balance the load among each and every server so that no server is overutilized or no server is underutilized as well. Next one is easy to expand. So we expect to use few time when adding nodes. So at any point of time, if a new computer system or a new user wants to add in a distributed system, then you can add it because it is a voluntary system. Voluntary system means anybody can join, anybody can leave at any point of time. Like if you go for grid computing project, I'll show you also some practical. So you will see over a period of time, the number of users are increasing, sometimes it is decreasing. So you can say average number of users are this much, but exact number of users are varying with respect to the time. Okay, so that is easy to expand. Any number of new users can add at a particular period of time. Any number of users can leave also at any particular time. Okay, somebody has some personal work, right? He don't want to share the resources from, let's say, 5 p.m. to 7 p.m. He can opt out. And after 7 p.m., that user wants to again participate in the system. Then he or she can participate. The next one is related to the performance. Performance means parallel computing can be considered as a subset of distributed computing. That's why I told you, you cannot find a complete difference between parallel and distributed computing. Although we have tightly coupled and loosely coupled local memory and shared memory, these concepts are there. But exactly, you can see when you go for such type of this distributed system, in each and every nodes in the distributed system is doing parallel processing. That's why this parallel computing is considered as a subset of the distributed computing paradigm. So not all application you can run in distributed computing. Like if you have a large application which cannot be decomposable. Like I told you a simple calculation 1 plus 2 plus up to 100, and I have shown it's how you can decompose it into 10 parts, or you can decompose it into 20 parts. Right? You can do it. There is no issue. Right? But all other applications, whatever you consider, that may not be decomposable also. In that case, you cannot apply distributed computing. Okay, all type of applications you cannot apply distributed computing. First, you have to see whether you can decompose a particular application or not. Based upon the nature of the application, you can decide whether to go for distributed computing or centralized computing is good for that particular application. Again, when we look into the performance is of two types. One is called as computing intensive, another is called as data intensive. Like your objective may be how to make faster computation, or your objective may be to store some data in the distributed system. So when we go for compute intensive, the task would consume a lot of time on computing. Like the value of pi, right? The value of pi is 22/7. So in order to calculate the value of pi, there is a simulation that is called as a Monte Carlo simulation, which is a very famous simulation. So in order to calculate the pi value, we are using Monte Carlo simulation. Okay. So for this, you need a lot of time computation. Like you have written a particular program, in order to run that particular program and get the output, you require 24 hours. Let's say, like whenever you do a big work, you will come to know this thing. So that such applications are compute intensive applications where you have to spend more time in computation. On the other hand, if you go for data intensive, there the task deals with a large amount of storage or large size of files. For example, let us take an example of Facebook. We are uploading our photo when we go for picnic, when we go for any meet, when we have some celebration. Sometimes we upload hundreds of photos. Each and every photo may be of 4 MB to 10 MB, something like that. So there we do not need any computation, large amount of computation. What we need? Large amount of storage. Dealing with large size of files, dealing with indexing of such files, right? So Facebook, there is another experimental data processing that is called as LHC, Large Hadron Collider. So they are example of your data intensive application. There is another important property that is called as robustness. Robustness means at any point of time there is no single point of failure. Right? When you go for a distributed system, if a system is failed, I told you, it is not going to impact other system. Okay. In terms of performance, there may be a slight interruption, but the entire system is not going to be collapsed. But if you go for a centralized system, like in network, you have studied something called as star topology, right? In star topology, all the nodes are connected to a hub or a switch, right? So if these computers want to communicate, they have to communicate through the centralized unit. But if the centralized unit is failed, then what will happen? The entire network is collapsed. So when we are talking about distributed system, you have to assure that there is no single point of failure. Or if a particular unit is failed, the entire system should not be collapsed. So other nodes can execute the same task executed on the failed node. That's why there is a concept that is called as a replication. What replication says? Replication says that there is not, when you assign a particular work, there is not only one computer system. Sometimes, suppose you have divided one task into 10 different subtasks, right? This is one task. You have divided into 10 different subtasks. But you have seen that there are 15 different computer systems are there. So you can duplicate any 5 tasks which you think which is more sensitive, and you can make this 10 task as 15 tasks, and you can give to 15 different computer system. So what will happen here? If a particular system is failed, okay, if a particular system is failed, then its replica may be executed in another computer system. It may or may not be, right? So if it is executed in another system, then it is not violating your performance, right? So if the first computer system and seventh computer system got the same input, first computer system is failed. So seventh computer system can execute and return that particular work. That's why it is not going to impact the overall performance of the system. So these are the basic related to distributed computing. Okay, we'll stop here. Next class we will continue related to other computing paradigm like cluster computing, grid computing, utility computing, and details related to the cloud computing. Okay, thank you everyone. If you have any questions, you can ask.